and to let me know if you have used SQL before. How many of you have used or not used SQL in the past?
This is Renee. I'll go. No, I haven't.
Yes.
I have not too much experience with SQL. I've done like a data camp course, but really, and then I tried working on stuff on just playing around on my own machine, trying to understand it. But
okay, good. That's fine. Okay. So I'm using the official background for the meeting. Is that okay? Or is it too weird?
Yeah, it looks kind of makes you look a little like a ghost. Not trying to be funny, but it seems like it's blending everything together.
Okay. Okay, so let me, okay, that's better, right?
Yeah, looks good.
Okay, amazing. So, okay, so, okay, so based on the previous comment, there's no much experience with SQL. And how many of you have used R in the past? Now you can write it. Yes, that's a question from Renee.
oh no, sorry. Just to say that, yeah, I'm pretty comfortable using R.
Okay, we have one. Okay, how many of you are pretty confident using R? Just Renee. Okay.
Sorry,
okay,
I think
so,
a few of us are like doing various emojis to show that we are. So there's like 3.
okay, that's good. Okay, so let me share my screen now. Okay, can you see my screen now?
Yes.
Good. Okay, so this is a crash course on SQL, on Postgres SQL, which happens to be a flavor of SQL. Think of SQL as ice cream, so that Postgres, it's like a chocolate ice cream, but you also have strawberry, vanilla, and pistachio, and a wide range of different flavors, right? So we will be focusing on Postgres SQL, because in my opinion, it's what gives you less headaches in the long term, right? Okay, so I have to admit that Postgres is not the easiest option to start with, but once you get it configured, all of the rest of it goes really smooth. There are another options which are more easy to configure, like MySQL, for example, or Maria database. But when you start using it, then you start getting problems with the access to the tables, which users can access a certain table or a part of the table. Yeah, that's especially sensitive when you have a confidential data or data from customers, like health records or information that you don't want to be openly available for anyone inside your organization, right? Yeah. So, for example, in the past, I used to work for a bank. I was working in commercial banking for a long time, and I had to create a lot of SQL databases for my team. And one of the tables contained the national ID number, which it's like the passport number, but for homeland purposes. So I didn't want that to be available for anyone in the organization, because providing that table with full name, address, national ID number, and another fields made it too easy to identify a customer and cross that information with other data sets. And that's something you don't like to, right? Right or not? Maybe somebody believes that we need to release everything. Please comment. We can discuss. This is not an absolute truth, of course. Okay, so I would like to know your opinions before we move to writing tables and all of that, because there are some quite important privacy concerns with data, especially with large data sets, which is what you will use SQL for. Sorry, I am talking too much. Maybe it's my accent too thick, or maybe I'm muted and I'm not realizing about it.
You're fine, Pachá.
Okay, thank you. Okay. So now, before we move, just another quite important disclaimer. What I'm gonna mention now can work with Oracle database, with SQL Server, with other proprietary databases, but it's gonna be much harder to configure because, for example, Postgres or Maria database or MySQL, because it's open source, the drivers are really well polished and the community knows all the moving pieces of the SQL engine. So the integration with R or with Python or even with Excel tends to be better with these open source SQL engines. Okay, so too many words now. So I'm gonna move to DigitalOcean now, and I'm gonna create my own server. I'm gonna start like from zero, but instead of creating a vanilla Ubuntu or Debian server, I'm gonna use a pre-made image, which is like those boxes that you buy in the supermarket that you just add water to them and you obtain a cake, right? Otherwise, it's like buying the flour, the eggs, the baking powder, all by separate, and then combining everything to get your own cake. And in this case, SQL is the cake. So I'm gonna use a recipe that's like an instant recipe that somebody else made and decided to put it all together into a package, right? And that is the supervised Postgres image. It's an image created by Superbase on DigitalOcean, which DigitalOcean, it's a cloud service. It's a really good one, actually. And I will like to know how many of you have used DigitalOcean or Linode or Amazon in the past. No, nobody?
Nope, me neither.
Okay, that's okay. So I assume you don't have a DigitalOcean account. So in the chat, if you want to follow the steps, there's a link. That's my link. So I'm giving you free credits if and only if you want to follow this tutorial. It's going to be recorded. You can follow this later. You can just look to this tutorial. It's fine. But it will be much better for you to follow this and ask. And please interrupt me, ask, comment. If you disagree with something, please disagree. Yeah, the right to dissent, I think it's crucial into a democratic society and especially in educational context, right? Okay, so this is a DigitalOcean. It has a dashboard once you create an account. If any of you wants to create an account, I can create an account with another email I have, and we can trace the steps together, or I can just create the droplet. What do you vote?
So the options were to either follow along or just watch. Was that what you said?
Yes.
I be willing to try to follow along, but if I get lost, I would start just watching.
That's not a problem. Okay.
Thanks.
So you only need to create an account, right? And once you create the account, you are gonna see this. Okay. So how do you create an account? Well, you paste the link on the browser. Here in the URL, that's gonna tell you that you have a referral link, and you need to register. Thanks. Yes, somebody reshared the link in the chat. Thanks. And once you get there, you need to sign up. Yeah. So I'm gonna create another account just for the people who want to follow the tutorial. Oh, no, it won't let me because I'm logged, but I'm gonna log on a private window and follow this. Okay, so I went into a private window. I followed the link, and now I'm gonna register with this link. Always sign without GitHub. Kelvin is asking in the chat. Yes, you can do that with GitHub. I've never done that, so I'm gonna do that now. Okay, and now it's asking me for my username and my password from GitHub, right? Okay, so I need to type I'm gonna put my university's email. I'm assuming that I haven't used that for DigitalOcean. So now I have to go to 1Password in my other screen and copy my GitHub password. Oh, sorry. Okay. Oh, it says invalid username. Okay. I'm gonna use my GitHub username. That's it. Okay. Now I have to check my 2FA code. This is something that's quite important for the email and all of that. So now I have to type the authentication code. Okay. And now I have authorized DigitalOcean to log to connect with GitHub. So I have created an account with GitHub, and I'm gonna link this to PayPal in this case. Okay, it says to confirm you need to make a small prepayment. This prepayment will apply to any future bills. Okay, so I'm gonna continue here. Can we do this without linking a payment method? I think it won't let me use it won't let me go ahead without adding a PayPal account and a credit card. Yeah, so I can do that from here and show you the rest of the steps, or I can just create a droplet from my other account, which already has an associated credit card, and we can use that server. It's your choice, basically. Okay. Yep. Okay, so if you want to continue creating an account, you can do that later. So here I'm gonna create the droplet now. So that's gonna charge a really small fraction. Yeah. If you create a small server, a droplet in DigitalOcean's language, it's a virtual server, a virtual machine. So here I click Marketplace, and I look for Supabase, and I click the Supabase Postgres. Okay. So I'm gonna create just a regular droplet. It costs $5 per month. So for this tutorial, this is gonna charge me a few cents. It's gonna be less than 10 cents for the 2 hours of the workshop. And here I'm gonna put this in San Francisco, for example. Okay. And I have my SSH key, which is associated to my university's email. Okay. And this is to avoid using typing a password every time. Actually, using SSH keys is more safer, actually. Okay. So now I created the droplet. And this is somewhat magical because this already comes with Postgres already configured for you. All the dependencies are solved, and basically you are ready to connect to this server and start copying data. Okay, that's pretty cool. Is any of these steps too complicated at this point?
Yeah, I guess I'm a little confused. If you could just explain what is this called again?
The droplet, yeah.
DigitalOcean and Droplet.
Yes. Well, DigitalOcean provides a service, a cloud service, where all the SQL data lives. Yeah. So so imagine that DigitalOcean, it's a neighborhood, and the droplet, the server, it's the same. It's a house in that neighborhood. So basically, you are renting a house in this DigitalOcean neighborhood. So the bigger the house, the bigger the server, the most expensive the rent is going to be.
That's a really good
Gotcha.
explanation. I think the issue is most people here have never worked with databases. They work
okay.
with R, but not databases. And
Oh,
so
yeah.
like the digital, like this isn't on your computer is what's the missing link.
Yeah, this is the cloud. Well, and the cloud is somebody else's computer in plain terms. And I'm doing this to emulate an organizational context because most of the times the data is not in our computer because the data is much bigger than our hard disk drive. Andrew is telling us that to host a PostgreSQL server in the cloud, you have to pay for some hosting service. Yes, as natural individuals, yes, we have as natural persons, we have to pay. But if we work for a company, the company is probably paying for the whole organization for a AWS account or like Node account or whatever. Yeah, if you're a university, probably the university has its own account with AWS or DigitalOcean. It's the same. So here basically I'm showing you how this starts from zero, right? Okay. Do you have more questions before we proceed? Catherine is asking us, so if we want to use SQL locally, can we? Yes. If the data is small, we can run SQL locally, but the biggest problem with that is that you will need to install and configure SQL on your computer and solve the dependencies and all of that. But if you want to share SQL data with more people, the cloud is a solution, because otherwise you will need to make your computer, a part of your computer, open to the internet, which exposes a security concern. And probably you will need to call your ISP and tell them, hello, you know what? I need to open these ports because my colleague wants to access my computer from his or her house. And the ISPs, most of the time, restrict that.
In that case, that would be making your computer a server, kind of, correct?
Yes, exactly. Yes, but if you work in a company and the company has a server, like a physical server, you can install SQL in that server and make your data available for your organization. Yeah, so that's the core idea, right? So now what I'm gonna do, and this is from now on, this is the same as connecting to a server that's inside your office, for example, or an AWS or Linode or any kind of cloud server that belongs to your company. Yeah, so now I'm gonna show you the terminal. So now when I created the droplet, I associated my SSH key with the server, right? Do you remember that step? So now, now that I have my SSH key associated with my server, I can do an SSH login, which is very similar to go into a physical server with a screen, a mouse, and a keyboard, and plug that to the server. So, but here I'm doing that remotely, but it's the same analogy. So when I run this command, it's like plugging a screen to a server and connecting there. So this is like some sort of teleportation that gives me access to the server, like if I'm right there with a keyboard plugged to the USB port of the server. So if you work for an organization, you don't want anyone to be able to plug something to the USB ports, right? You wouldn't like any person to go to your office and plug a USB stick to your server or your laptop, right? So for that same security concern, you don't want to give SSH access to anyone. Can we use your server? Yes, but now I need to authorize that. That's why that's why I wanted to explain the analogy with the USB stick. Yeah, most of laptops and servers in offices have restricted USB ports, for example, to avoid that somebody goes disguised as a janitor, plugs a USB sticks and copies data, right? Okay, so this here in this terminal, of course, it's my computer, but I have access the server. This is like a sort of inception. It's like me inside somebody else's dream. Okay, do you understand that analogy? Yes. Okay. One. Okay. Okay. So now I was logged as root as the super user. The super user can do something like that, which is basically delete the C drive on Windows. So also you don't want anyone to have root access, especially users who are not intermediate or expert users, right? So being root gives you great power, but also great responsibility. So now going back to Kelsey's question, can we use their server? Yes. Should we SSH into? No. I'm going to give you a more convenient access. I'm going to give you the access I want to. And it's also convenient access for you that gives you just access to the SQL parts of the server. So you can't delete the drives, you can't delete a dependency, you can't uninstall SQL or delete a database. Yeah. Okay, so I'm gonna hit this to get started. Okay. So this says once you have logged via SSH, you do this, and when I copy that, what's this gonna do? This is gonna switch from the root user to the Postgres user. Oh, sorry. I copied additional content. Okay, that's it. So now this has entered with the Postgres user, which is a separate user from the super user. The Postgres user is quite a powerful user in terms of what you can do and what you can't do, but it's more restricted, more sandboxed compared to the root user. And now I have to type this and add a password to this. Okay, so I'm gonna paste that and I'm gonna put a password. So I'm gonna put the password in the chat. It's gonna be ResBazAZ 2021. Okay. That's a super unsafe password, but this is for instructional purposes, right? Otherwise, you go to 1Password and pick a random password with 30 characters or something. Okay, so now you can go, you can log out of this. Then I have quit from the Postgres session in the terminal. I went back to root. So this is like a 2-layered thing. This is like a waffle, then maple syrup, and then another waffle. So now here I'm on the top level again, and now I'm gonna exit. So that's it. So now I can go to dbeaver, which is a database engine, a generic database engine. Just let me show you as an example. And this image, the supervised image, it's pretty cool because it has all already configured. Okay, so this has opened in the other window. Okay. So I'm gonna remove this new connection and I'm gonna hit the plug. And here I have different options. I'm gonna go for Postgres because we are connecting to a Postgres database. And this is gonna ask me to download the drivers, which is totally fine. I'm gonna do that. And this is like the most abstract and language independent way of connecting to a database. Yeah, can be Postgres, MySQL, whatever. And this, it's like the same for R users, Python users, whatever, because this is a SQL graphic interface. Okay, so here the host is not localhost. Let me go back in the chat. Like Catherine asked, if I have SQL configured on my laptop, this is correct. I'm gonna connect to localhost. I'm gonna connect to my own computer. But here I need to connect to this host. And this can be associated with a website instead of an IP. I'm gonna show that later. The database is Postgres, right? The username is Postgres, that's correct. And the password is ResBazAZ 2021, okay. I'm gonna put the password there and I want this to be stored in my keyring. And then I put test connection, okay? And it says it's connected. So does any of you has dbeaver installed? Yes, no?
I do
But
not.
that's okay. Let me show you how does this look like. There's a Postgres connection. There's a Postgres. Okay. And there are a lot of schemas here. The public schema is where the public data lives. And this is empty because this has no content. It's an empty database, right? Like an empty spreadsheet, basically. Okay. So now this is how you connect to a Postgres database. Now I'm going to close this. And from now on, I want you to open RStudio. If you have RStudio, if you have Python, you can connect from Python. That's okay. But this workshop is for our users. And from now on, you can access the server and follow this with me. Okay. So before we can do exercises together and ask and comment, I'm going to show you how to connect actually. And any of you will be able to connect, right? So how many of you have used the NYC Flight 13 database? Not me, okay. Yes, I have, but yes, Kelsey, it's the same database as in R. Yeah, as a data frame, probably, or a table. Yes, okay, thanks, Kelsey. Please unmute and talk. We haven't talked in a long time. Okay, so now here is the URL. If you want to type less, that's the code. And if you go to that URL, you will see a folder with today's date, and there you have a script that is code for a workshop. You can clone the repository. You can copy paste the code in RStudio. Okay, it's up to you. But now I need lights. Okay, that's better. Okay, so now I'm gonna move to RStudio for a while. Okay, and here I have all the code. So if you run a library NYC flights 13, and then you see the flights table, here you will see a table which is about an airport, New York's airport. And these are flights for the year 2013. And this table flights contains the year, the month, the day, on which time of the day the plane departed, when a plane arrived back to the airport, etc. Okay, Julian is telling us, I created a repository which you can launch in my binder, which has Jupyter and RStudio alongside a built-in Postgres SQL server. Oh, that's amazing. Cool. Cool, thanks. Thanks, nice resource. Nice. Who of you doesn't have a RStudio to follow this now? No? I have Studio. Okay, you have a Studio, right? I'll do. That's fantastic. Okay. Otherwise, I can go to DigitalOcean and create an RStudio server that it's one of my images and give you RStudio from the browser. Okay, but it looks like there's no need to do that. Okay. So probably you don't have the NYC flights package installed. If you can replicate that step, please go to the console and do install.packages quotes NYC flights 13. And if you type that, you are gonna reinstall the sorry, in your case, install the NYC flights package, and that's it. Okay, so please do that. I'm gonna wait for you. And if you could see this table on your computer, please comment the NYC flights database. Do you like it? You don't like it? No? And maybe you wonder why I'm using NYC flights, right? Why not? Why that, and why not Iris or empty cars, for example? Okay, Kelsey is ready with NYC flights 13. Okay. Okay, so what's the command to install the package? Okay, it's install.packages quotes NYC flights 13. Okay, so that's the command. I can wait while you install it. It's a somewhat light package. And also, let me show you the this book. There's a fantastic book, Art for Data Science. Maybe you know this book, right? No? This book is amazing, period. If you can buy it, buy it. The advantage of buying it is that you can have that signed by Hadley. I met Hadley Wickham at some point in Santiago de Chile. I invited him for a beer. He was an amazing person. And I met his partner, a super excellent guy, great people who shared a lot with the art community here in Chile. And instead of acting like rock stars, they were super nice. I just love them. Okay, so this is the NYC flights, and I've chosen the NYC flights 13 package because this has different tables, and the tables are connected to each other. Yeah. So, for example, as you can see in this diagram, you have the airport code, and in the flights table you have the airport code. So if you want the full airport name, you can do a left join between flights and airports and associate the airport code with the airport full name. Yeah, like SCL equals Aeropuerto de Santiago Arturo Merino Benítez, for example, or SFO San Francisco International Airport. Yeah, so things like that. Okay. So this relational structure is ideal for SQL, right? And this database is a light database. Yeah, for example, here I have the Chilean census, which is 6 gigabytes, but I don't want you to download 6 gigabytes because it's too much. Okay. And 6 gigabytes, believe it or not, is a small SQL database. There are SQL databases that are hundreds of gigabytes, and that doesn't even qualify as big data, because there's a lot of people who are like a con man of the statistics or something like that, and they go promoting the big data services which are not big data. And most of the times there's people in the industry who promote big data services who are no more than 95% of SQL queries and deployer, and that's their big data. So when you hear that something is big data, please do not trust that. Okay, so now we are gonna remove all the magic from what a lot of people label as big data. We are going to talk about SQL queries, which is something pretty standard in the serious industry, and it's something that has been done in the last 20 to 30 years with a lot of maturity and solves a lot of business problems. Okay, so we can see this table in R. Okay, so I've shown the R4DS diagram. Okay. So now let's discuss a bit about SQL indexes. Okay. So again, without any poetry, a SQL index is a copy of a table. So if you have a table like this table, a good index is something that helps to identify an observation in a unique way. Yeah, for example, if you have year, month, day, and departure time, that's not a good index because two different planes could have the same departure time, right? Right or not?
Right.
Yeah, but
See,
thanks.
Pachá, we're shaking our heads, but I don't think you have our cameras on.
Oh no, but please, if you have questions, please ask. I can repeat that again, okay?
No, we're like, yes, just
Oh.
nodding our heads and you don't see us.
Yeah, so if
We
you don't
will
want
speak
to,
next time.
yeah, please. Or if you are shy with the cameras, you can just yell, yes, we understand. Or you can say, no, we don't understand, or something, okay? Yeah, but, okay. A good index, for example, could be the year, month, day, the departure time, and the tail number, because the tail number is like in the license plate. Yeah, so unless an airplane decided to copycat somebody else's plane, the tail number is going to be unique. Yeah, but what we want to identify uniquely for an index is not the plane, not the license plate for the airplane, the airplane, but we want to uniquely identify the observations. Yeah, so the same airplane can go to a nearby city, go back, and repeat that a lot of times during the day, but still we would like to identify each observation, each flight. Yeah, with independency if it was the same or other plane, right?
Right.
Okay, thank you. So basically, the index takes the table and picks a few columns to identify the observations and creates a separate subtable. Yep, and that helps to identify when you filter, the index is going to help you to select. For example, the SQL is going to know that, for example, if you want the flights that departed, let's say, before 6 a.m., SQL is going to go to look into the indexes and tell itself internally, you know what, you need the rows number 10, 11, etc., up to row number 100. And it returns those rows, okay?
Okay.
Thank you. Okay, also, this is important. We need to distinguish between a unique index and just an index. An index, for some purposes, can have, let's say, a repetition, yeah? But unique indexes do not allow repetition because of what I've mentioned about that you need a unique way to identify the observations. So for example, for the airplanes table, a unique index is a carrier. Yeah, so let's look into that table. So, okay, let's look for airlines. Oh, sorry, I need to load the package again. Okay, so that's airlines. So if you want a unique index, airlines, which is the table, needs a column with no repetitions. So if I have 10 observations, I need 10 unique observations. Yeah, so let's do an analogy. If I have a table with name, family name, and address, probably that's not a good that's not even useful. That's not even feasible for a unique index. For example, if John Doe lives in Fake Street 123 and his son is also John Doe, the address is going to be the same. Kelsey is asking, this is also called a primary key. Yes, thank you, Kelsey. A unique index is also called a primary key. Yeah, so if we have John Doe and the son of John Doe in the same house, that information is not useful for a unique index or a primary key. But if we also add, for example, the age, that makes a unique index or a primary key. Yeah, okay. Also, let's look the planes table. So in the airlines table, the index is going to be the carrier. Okay, because the carrier it's short, it's useful for a filter, and is associated to the full name of the airline. If I look into the planes table, my unique index or my primary key is going to be the tail number, yeah, which is like the license plate. Yeah, so for example here, just to be even more repetitive with the example, the type is not useful for a primary key because many planes can have fixed wing multi-engine, correct? Okay, so after repeating this a lot, is it clear what a primary key is?
Yep, makes sense to me. It's the unique identifier in the table. Right?
Yes, yeah. Thank you. So we have Austin, Kelsey, Catherine. Yeah, so for example, if we have a table with imports and exports for different countries, the exportation column is not good for a unique index because the exports is a continuous variable, and continuous variables are not useful for unique indexes. Yeah, that's also important to take in consideration. Okay. So now I'm going to create here a list. So that's my list of unique indexes that I mentioned. And for example, if I look into the airports table, I'm going to provide another index, which is the FAA, which is the civil aviation code. And for the flights table, let's give it a few seconds. Okay, that's it. My index is going to be a composition. So for the flights table, I'm going to have a first index with year, month, and day. That's one index consisting in 3 columns. I'm going to have a second index with the carrier only. Then a third index with the tail number. And a fourth and fifth index with the origin and destination, respectively. And for the weather, I'm going to do something similar. So I'm going to create that. So that's it. So for example, for the weather, I have 2 indexes. The first one consists in 3 columns and the second one in 1 column. So now I'm gonna load the add Postgres package finally. So if you don't have the add Postgres package installed, please type what I'm gonna paste in the chat now is install.packages add Postgres. So before doing that, please verify that you can load the add Postgres package. Okay. And if you use Ubuntu, please let me know, because Ubuntu needs a dependency, a system dependency for add Postgres. Got it installed here. Thanks, Justin. Okay. Catherine says, all good over here too. Thank you. Okay, we have two. We had two in less than 10 seconds. So in 1 minute, I assume everyone is going to be ready. Okay. Renee is ready. Thank you. Okay, while we wait for the rest, one of the large advantages of SQL, because the connections and all of that are somewhat complicated, is that you can create an organizational package for your university, your research group, your lab, your company, whatever, and you can provide functions for the end users so that they can only need to call a single function like a connection one, enter, and they open the SQL connection without typing passwords and any of that. Kelsey is done. Thank you, Kelsey. Okay. So now I do library Postgres, and I'm gonna run this function that I have here. And this is a function that inside is calling a Postgres connection throughout the add Postgres package, which is also calling the DBI package. So there's a whole circle of dependencies that make it possible. It's important to mention that here I can go and put DB name like Postgres right away as a string, but here I'm calling an environment variable because I wouldn't want to put a SQL password by accident on GitHub. That's important to mention. It's not a good practice to put passwords on scripts, right? So here I'm calling environment variables with the database name, the username, the password, and the host. So if you want to do that, I can do something like edit add environment. Oh, sorry. I have to use this double quote, double dot. Edit add environment. So that's it. So once you have loaded the package at Postgres, please type that I put there. This is a shortcut to edit your environment variables. Yeah. So here I have removed the environment variables that I use on a daily basis because I don't want to share that on Zoom, of course. And this is the safe way to use passwords and all of that. So I'm going to stick to the safe method, even when that's an additional step. Okay, so I want to show you the good way. Yeah, I don't want you to go to an interview later and show so that you show your amazing art package, and the interviewer tells you, hey, and why do you have a password as a string there? And you say, no, Pasha told me, and that's not gonna be good for you and not good for me. So I'm gonna put tutorial DB. The database is Postgres, right? I also have to type the tutorial user, which the user is also Postgres because it's the default in the Supabase Postgres image, right? Now I have to put the pass, which is ResBazAZ 2021. Yes, but suppose that you work for the, let's say, something sensitive like the, what can it be that's sensitive? Like the, let me think about a non-controversial example. An insurance company, for example. Yeah, or you work for, let's say, for Pfizer, and you have a database with the names of all the people vaccinated. Yeah, you don't want to accidentally put the database and the IP or the website, the URL to access the database and put that by accident on GitHub, right? Yes?
Yeah, definitely not.
Yeah. Yeah, or for example, let's say you work for the EPA, for example, the Environment Protection Agency. You don't want to share the personal information of communities affected by contamination, right? So you want to keep that for a restricted audience as a matter of data protection, which is very important. Okay, and finally, I have to type the host. Okay, so now the host, I don't know that number because it's an IP. So it's that number, okay. So now I paste that and I save. Okay, how many of you?
In the chat?
Yeah, sorry.
Can you paste that one in the chat?
Oh yeah, sure. Yeah, I wanted to show you this and also discuss a bit. Okay, that's it. Okay, so now let's explore this. If I select that and I execute that, it's empty. Why? Because environment variables are static. So now I need to go to session, restart R, and after restarting, the R session knows the new environment variable. So if I call that variable, I have that there, and not an empty string. Yeah. So I'm gonna load library at Postgres again. Now I call my function, and this is just a function with a connection, a call to a connection, sorry. Yeah, so now I'm gonna edit that in the scripts later and push that. So if I want to explore the tables, I have that option. I can specify a schema, open a connection, and run a SQL command. Yeah, but I've just realized that this is not the best option. Okay, so let me comment this. Oh, sorry. Okay, so you can type that if you want, but what I'm going to do that is open a connection by calling my function. That's what I will do in the context of an organizational package for my research group. So I create an object con with double N, which is it's calling a function, and the function opens the SQL connection. Okay. So now I can, for example, call DBI and put DBI list tables and type my connection object name. And that shows me nothing because I don't have tables in my database, right? Okay, and it's also important that when you are done working with a connection, that you will close that open connection. Yeah, this is like the shower. When you take a shower, okay, you open the faucet or the pipe. Yeah, the water starts running. And when you are done with the shower, you just don't want the water to keep running. The same applies to SQL. So you need to close the connection. Kelsey is asking what's in the sprintf. Is that the SQL query? Yes. What's in the sprintf here? It's I can show you this, but it's not the best option. Let me comment this. This is the same but shorter. This function does exactly this. This is printf. This needs a schema object, and if I execute that printf, that gives me a SQL query with no add sugar syntax, right? So the difference between this and this is like giving a pill, a medicine to your pet. Instead of giving your dog the pill right away, you put that into a cheese or something and give it to the pet. That's what DB list table is doing. It's giving us a cheese with a SQL pill, this guy inside that. Oh, thank you, Kelsey, for the 10. Do you get Julian? No, Julian. In the case of Ubuntu, you need the libpqdev dependency, which is installed via apt. But in your case, it's something deeper. It's something like more even spiritual, if you want to, because you have a problem with the standard C++ shared library. I'm happy to discuss that later. We can do a separate Zoom. You are gonna probably need to fix broken dependencies or even jump to a more updated Ubuntu version. Yeah, I'm happy to help you, but that's like the problem with that, with the standard library. It's a question like which is the right PhD program for me. There's no closed solution for that. Yeah, I'm happy to do that later. Okay, so this is the SQL query. So now, because I have closed the connection, I have to open the connection again. So I call line 46 again. I have my schema, and I'm gonna execute that, right? And sorry, one more parenthesis because I forgot the selection. Okay, and now if I explore that, it says that I have 0 tables. It's not surprising. And now I close my connection. Okay, and what I did there was to put my tables list of tables object as a character object instead of a list. It's something to simplify. So now I'm gonna copy the tables. So I'm gonna list the tables in NYC flights 13 package. So these are the local tables I want to copy to the server. And now with, sorry, I need to call this step anyways. I have my remote table there. Now I convert that to a character. And now I can do a set diff. This is a difference of sets. It's like you know
What's
what
in
you have.
one and not the other?
Yes, what belongs to one that's not in the other. Exactly.
I have a question, Pachá.
Yes, of
When
course.
I do the remote tables, this is why I'm asking, because I don't want to get too ahead of it. It says it's empty. I have nothing.
Yes,
Is that correct?
it's correct because I haven't written anything to the
Okay.
SQL server.
Good. Thank
Yeah.
you.
So with this set diff, I'm gonna do an exclusion. I'm gonna exclude and get a list. Sorry, not a list. A character vector of all the tables that I need to copy to the server because my previous query could not find those tables in the server, right? So these tables here, at this point, only live in the NYC flights package. Thank you, Kelsey. Yeah, and I do that to avoid duplication or overwriting. Yeah, because this is SQL. The data here is small, but SQL sometimes the smallest table is 200 gigabytes, and you don't want to overwrite that. Okay. So now here I'm gonna. You don't need to do this. Please don't do this. I'm gonna do that. So then we all run queries, but let me be the only one copying the tables here, or otherwise, if we do all of that at the same time, we are gonna collapse the server and make everything slow. So there's a solution for that. Is the server hangs, I can push the green button here, which is basically like going to the plug and pulling the plug and disconnecting the computer. And then I can plug that again. So please let me run this here myself. And then we work all together and we interact with the server, right?
Great.
Thank you. So here what I'm gonna do, I'm gonna, for each of the tables in my character vector, I'm gonna call the table as a data frame. I'm gonna open a connection, and with the copy to function from dplyr, I'm gonna copy from my computer to the server with the indexes I've defined previously. But because I've restarted the session, I'm gonna need to execute this again. And then for every time a table is gonna be copied, before copying, it opens a connection here, and it closes the connection when it's done. And the table name is the name of the table. The data frame is the result of evaluating each coordinate of this character vector. Okay, so just to show you, let me type here below, for example, table equals planes, right? So here it's gonna tell me, it's gonna create the data frame. This is evaluation. And if I put df, this is the planes table that now it's called df for the purpose of copying. Then it's gonna print a message. It says creating table planes. Then it's gonna give a name to the table for the SQL part. I have that there, planes. Then it's gonna open the connection, copy, and disconnect. So now I run this loop, and okay, it says could not find function copy to. So we need to do library. Maybe I didn't do that previously. No. Oh, yeah. That's before I forgot to mention that example. My fault. If you have used the pipe, SQL allows to use dplyr with SQL, which is a very powerful solution, actually. Okay. Now again, and that seems to be going well. That's it. Now it's copying. So if you want to take a short break while this copies, the rest of the messages are gonna be just like this. You can go walk a bit, stretch, take water, please. I'm gonna go for a glass of water and I'll be back in 30 seconds. Okay, thank you. Okay, I'm back. If you want to stretch a bit more, please do that. If you have questions, please ask. What else? No,
I'm here.
Kelsey. Okay, okay, good. Okay, so let's resume. Okay. Yeah. So this is ready. This has copied all the tables. Okay. So now we can access tables. Okay. So if I want to access a table, I have to open a connection now, and I'm going to read data from the server. So here I'm going to open a connection. And here, for example, if I want the number of observations per month in the flights table, the first part is how do I call that table in the server, right? So that's the TVL function from the deployer, where I specify my connection. That's there. It's a SQL connection, a Postgres SQL connection, and I specify the table name. So if I type that, it's very, very, very similar to the flights table. So let's compare.
You need to reload New York City flights.
Yes, you're right. Thank you. That's it. So here it says a table with more than 3,000 observations and almost 20 columns. Okay. This is on my local. And this is on SQL, where it says source, table flights. Okay, same number of columns, 19. But it has no way to know beforehand the name of rows, the number of observations. Also, it says that the database is Postgres. It tells me the username, the host, the port, which we use the default port, and the database. Yep. Okay, so we have the same table, but we're reading it from SQL. So when we type TVL, it reads a preview limited to 10 observations. Okay. And now we can do a group by year and month. This is just a deployer. And then we can do a count, right? So if we type that, then we have the result. So January had this number of observations, February this number, July this another number, etc. And then the collect function, which is something that we don't use when we use a deployer with data frames or tables. It's something that moves, imports the result of our query to a local data frame on our computer. So if we, for example, if we execute that, how do we collect? The obs per month is a list. So every time I want to call this observations per month, this has to run the query again. So if this is a large query, this can take 10 minutes every time I did this. And to avoid that, I type collect. And this here is going to be converted into a data frame. That's it. And it was converted into a data frame with 12 observations and 3 columns. So if I type that now, it used to be a lazy query with an unknown number of observations because this is a pre-visualization. But now here, this is the complete result of the query, right? So this is SQL. So we may wonder what this is doing. So I can copy this, move that below, and instead of collect, I can type show query. And that's gonna show the internal SQL translation that the deployer is doing in order to ask the server exactly for what we need. Do you have questions about this?
So in this case, we, if you're using tidyverse, you don't need to learn the SQL syntax. They're translating it for you.
Unless you need a SQL function that's still not translated to dplyr. You see, that's a good question. Thanks. For example, here, when we do the group by, which is dplyr, we group by year and month. And in SQL syntax, this is select year and month. And then we do a count, which is translated as the count function in SQL. And the count column is going to name as n, because n is the default counting column in dplyr, right? So, and then in the SQL query, this specifies from which table, which we specified before. So in dplyr, we put flights and then the group by. In SQL, we put the columns that we want, and then we specify the table. And finally, the group by is per year and month in the SQL query. So there's a permutation of orders, and please try to understand this as a translation. If dplyr is English, SQL is probably French or German. So it needs to translate, but not all the words in English have a translation in German or French. So for most of the cases, you are going to be okay using just dplyr with this SQL backend. But if you need something super specific, you are going to need to write the query like this, right?
That makes sense. And so this is all based on dplyr. What about dbplyr?
Yeah, well, dbplyr is a dependency of dplyr. So when you call tvl, you don't do library dbplyr, because tvl imports those methods from dbplyr.
That's cool. I thought there were two separate kind of things, but no, they're dependent on each other.
Yes, yes. Dplyr is more on top, and think of like an iceberg. So the tip of the iceberg is dplyr, and the part of the iceberg that's below the water is not just dbplyr, but also ResBazAZ and DBI. DBI, it's like the most deep part of this SQL stack in R. Yeah, or you can think like something like this. Let me. Well, I assume that all of you have seen something like this, right? So dplyr is like the top level, then goes dbplyr for the tvl function and all of that. And then on a more deep level, you have RPostgres, RMySQL, RMariaDB, and DBI. Yeah, and the base functions are really, really, really down deep in this stack of cakes. I think it's a good analogy. Yeah, Kelsey pasted a summary. Thank you, Kelsey.
That's very interesting.
Yeah, and I'm putting this instead of the iceberg picture, because here each cake is a package, but these cakes live on different levels. Yeah, so the iceberg analogy is also good, because the underwater part is the part that the user doesn't see and has no need to interact to. Yeah, so that's how you access a table. Could any of you run this example to group by and count in SQL?
Can you ask that again?
Yes. Were you able to run this example successfully?
I was.
Okay, thank you. Thank you. So now I'm gonna close the connection, and that's how you interact. So let me go back to add for data science. I need to move this. Okay. So for example, this, let's see if we can replicate this example from the player. So, okay, it's gonna return 3 rows and 6 columns. So now I need to open the connection again. So, okay, now I have opened the connection. So we don't use weather. Well, for the comparison, yes, but we have this done locally with the NYC flights package. But now I can do the same, but in SQL. So I type TBL, con, comma, weather. And then I can do that. Yep, so that's it. So this is locally with the data frame, and this is with SQL. Is it clear?
Yeah, it makes sense. That's pretty cool.
Thank you. Okay, so let's go back to this. This example, it's a quite simple example, actually. Yeah, but okay, let me stick to this. Do you understand what a join is?
Yes. I think most people
Thank
here
you.
do.
Good, good, good. Okay, so now let me run an example with joins. So I can do this. I can do TBL connection, and let's say flights. So this is a preview. It's a query with 10 rows. And for example, I can cross the origin with the airports table, right? So for example, if I have that and I have the flights table in SQL, if I have that, then I have the code. Yeah. So I can, for example, pick this and do, let's say select, let's say origin or group by origin. And if I do a count, I'm gonna know how many planes came from those origins, right? Right or no?
Yes.
Thanks. So now, for example, I can do an inner join, which is a good join for SQL, especially for large tables. And I can do a join by join between flights and airports. And I'm gonna put by origin equals FAA, right? And let's say I don't want the latitude and all of that. So here inside the join, I do a select FAA and plane. And that's it. So now I have the name, the full name of the airports and the number of planes that came from that origin to New York's airport. And all of that is done in SQL, and the final result is being sent from the server to my computer. So this is very efficient. Instead of copying complete data frames from one side to the other, I send a query and it gives me a small data frame as a result.
That's very cool.
Thank you. Thank you. So now we can move to other types of data sets with other types of connections, right? So now I'm gonna disconnect this. And look, before I move to other database, I'm gonna open the Beaver again to show you what we've done with R in the server. So if I now go here, if you remember well, this didn't show tables. So I'm gonna open this and I'm gonna show the public database, sorry, the public schema. And here I have all the tables I've copied from R, right? In addition, and before going forward, here you have the slides. If you want to append new records, you can do that. You can use db write table with the append option set to true. Sorry, the append argument. And you are, if you do that, you are going to add more records to your database in case that you have an authorization to write in that table. Yeah, you can delete records from R as well. You only need to read the DBI documentation. I'm gonna send you the link right away before I forget. And actually DBI, it's an excellent package. Where is it? No, it's not this one. This one. Yeah, so in this case, you may wonder why we use the RPostgres package when we have DBI. And RPostgres provides a Postgres driver for DBI. That's what you do. Okay, so this is the DBI documentation. It's excellent. But if you want to append, let's say that you have more than 10 million observations in your data, you can use a for to write by smaller pieces, right? You write by parts. And because this is like a quite complicated syntax with brackets, with all of that, you can also use the tidyverse. Yeah, so if you have a not so good internet connection or whatever, you can partition your data and create a list, and then with the map function from pur package, you can pass this inside a map, and you can write by pieces. Like instead of writing 10 million right away, you can write in batches of 1,000, so 1,000 rows or 500,000 rows or whatever you like, right? Does it make sense?
Very fancy tidyverse.
Yeah, thank you. Thank you. Well, this is more fancy than that.
Well,
this is
yeah,
like
I like the second one better.
Yeah, this is like the opposite of tidy. This is very tidy.
The only thing I would do is add glue instead of sprintf, but that's personal preference.
Oh, yeah, you can use glue. Yes, yes. We can do that right away. Let's say that
there's no requirement, Pachá. I was just commenting.
Oh no, but I mean like to show how to write in batches. We can do that. I'm gonna add this now. This is like pure improvisation from now on. Write in batches, okay. So let's say I have a data frame, df. I'm going to create a table where x is an add unif, right? So let's say that n, give me a value for n, please. 1 million, 2 million, 3 million.
12 million.
12 million, okay. Okay, run if n. Yeah, so I'm gonna put that, and x is gonna be an r norm of the same thing, and theta is gonna be an add binom of the same thing. Oh, sorry, no, that needs more arguments. Instead of a binomial, what can it be? Uniform and normal, and what else? No, yeah, those two. I don't have much imagination at this time of the day. Okay, so I'm gonna do that, and this is my 12 million table. So that's it. It's of course fake data. Okay, so now I'm gonna call it tidyverse to load the put and all of that. Yeah, so now I'm gonna call my df again. And based on the row number, I'm gonna add a mark, a p mark, like a first block, second block, third block. So this is like dividing a city like Boston into different subdivisions, like Cambridge, like what else? Alston, like what other do you have in Boston? Somerville, all the counties, right? So if this data frame is the city, now here I'm gonna partition this in counties. Okay, so now I'm gonna do that. And my data frame was converted into a table, pardon, sorry, from a data frame to a list of 2 elements, right? So maybe 2 elements is too much for, sorry, it's too little for 12 million rows. So now I'm gonna create a data frame again, and instead of dividing by n, I'm gonna divide in groups, dividing groups of let's say 100,000, right? So now I do that again, and my data frame is converted from a single data frame into a list of 121 pieces, right? So if I do df, let's say df piece 1, it contains almost 100,000 rows. If I call the second piece, the same. Yeah, this is 100 because of how I made the division with the floor function for the truncation. And if I call, let's say, piece number 5, it's the same. It's a piece of 100,000 rows. Okay, so now with the map, I'm gonna call the df. So I'm gonna do a sec along, which is basically gonna take the first piece, the second piece, the end piece, up to the 121th piece of this list, which is a partitioning of my original data frame. Then I'm gonna do sprint, and okay, I didn't load glue. I'm gonna load glue again, because like Oscar Wilde says, the audience makes the writer, right?
And glue is just a beautiful function.
Yes, I agree. Yes. So my idea, besides the beautiness of this, the idea is to make the audience happy. I hope you agree with that. Otherwise, it means you have a problem. Okay, so that's with glue, right?
Yes.
Okay, so that's gonna tell writing fragment 1 out of 121, 2 out of
Oh,
3
it
out of
shouldn't be flights
etc.
14. It should be DF, correct?
Yes, yes, thank you. And then I open a function, I write with append, and this is gonna be a new table we are gonna call df example, and this is gonna be df. And the brackets are to call this the fragment in the list, right? So I'm gonna do that with append. So the first block is written, then the second block is written below that, and the third one is below the first two, and so on and so forth, with no overwrite. Otherwise, we are gonna be deleting the previous step, right? So now I'm gonna do that. So this opens a connection, writes the fragment, and closes the connection. So now I'm gonna do that, and it's gonna start writing to a new table, which is df example. Yeah, so here is writing the first fragment, the second fragment, then the third fragment, and so on and so forth. And while these copies, I can go to dbeaver, I can refresh this, and I'm gonna see the partial progress of this process, right? So if I go there, I can see that this has 2 columns. And the magic of SQL is that even when I'm writing, but SQL is more slow when I can hit this and say x from df example limit 10. Sorry, that's syntax. That's it. That's it. And that is gonna show me the first 10 rows in the server. Yeah, so this is like a triangulation from R to the server, and then from the server back to dbeaver, back to my computer, right? And that is writing the fragments, and that's going quite well. Yeah, so there are mode options. Actually, you can use SQL locally, and there are very good packages to use SQL locally. For example, if you are writing an article, if you can use, for example, an embed SQL like DAC database that needs very little configuration. I can show that while this is copying, but I have shown you that this works. I'm gonna open a new R session. For example, this is a package that I created because I was very tired with the ResBazAZ format, census format, because that was a format that was Windows only, and I needed to get a length laptop, and I had to click a lot into a graphic interface. So I decided to extract all of that information, put that into a SQL database, and create a package with SQL connections so that the user never has to fight with SQL and never has to fight with ResBazAZ, because I got very traumatized from that process. So I don't want to pass that trauma to the next generation. I think it's the good approach instead of replicating the process, right? So I'm gonna do library censo 2017, which is the Chilean census. And if you were paying attention, I have here this function fun connect that is defined here. And you can put a function like that in a package so that you can create an icon here, a direct access link to the SQL database, where you have a list of the tables, where you can preview the tables like that. And here, what can I do? I can do, for example, censo underscore tabla, census table in English. And I can do, for example, comunas, counties. And that gives me a SQL table with the collect statement in the player. And it gives me the table as a table right away from SQL. Where does this information live? It's in my home, in the local folder. Then I have to go to R and then to Censo 2017. And there I have the table. And it's a 6 gigabytes database. Yeah. So with this you can do a lot of things. Let me show you the beginners in the meanwhile. So here I'm gonna load a few packages. Right. Oh, I don't have the Chile mapas. Okay. I'm not gonna use the Chile mapas for now. It's a package to create maps of Chile. If you would like me to show the map, please tell me and I can install that. But here, this is just deployed, you see? So here I'm interacting with the database that lives on my computer. And how can you install this census package? Well, this package is available from CRAN, so it's install packages Censo 2017, or just a better option for the updates and all of that. With the remotes package, you hit install GitHub, add OpenSCI/Censo 2017, right? And this configures the dark database in your computer and all of that. Yeah, so for example, here you do library Censo 2017, and here you type a deployed chain. So this basically is gonna tell me the number of people who lives in a region of Chile, but grouped by educational level. If you notice, this example took just a few seconds. That's the magic of indexing and using SQL, because this explores a 6 gigabytes table, but it knows exactly where to explore. Yeah, so there's no lost efficiency by doing a reading of the complete 6 gigabytes. So here I hit play. It's 1, 2, 3, okay, 4 seconds. We can run the system time command to get the exact time, but it's pretty fast to explode and aggregate 17 million records, which is the Chilean population, right? So if I explore that table tells me where the people are located in the census divisional zones with their educational level and all of that. And now I can do an additional aggregation per commune, per county, and educational level. And I can print that. And then I have the educational level and the number of people with that educational level. So now I can cross this. This is to create the map, okay? But also, if I want to know what of this each of these means, I can go to the connections pane and look, for example, the variables codification, okay? And here I can look for the P10. Sorry, no, not P10. Sorry, it's P15, right? So I can look here for P15. Yeah, this is also SQL. And this is the full codification for the variables. and this makes it much more lighter to store. Oh, sorry. I'm gonna do something here. I'm gonna do TBL sensor underscore database. This is a shortcut to open a SQL connection for a person who doesn't know SQL. And here I'm gonna call variables underscore codification, and then I'm gonna do filter variable double equal p15, right? And this is gonna be let's put this educational code, and I'm gonna do a collect. Okay, so now I have my labeling for the educational code column, right? So now what I have here, this educational level, I can do a left join with educational code, right? And it has to be by level underscore educational level equals value. So now I can conclude that, let's say, 8% of the population has a technical degree, community college degree, in this region of Chile, in the Biobío region. And for example, let's say the number of people with just primary school is almost 15%. Is really high compared to other regions of Chile. Yeah, and that's for that county. Yeah, so you can explore that for the different counties of this region, and that's it. So you will agree with me that it's quite fast to obtain this in a few seconds, considering that this census database is 6 gigabytes. Yeah, if this was a CSV file, I will need to read this, prepare a tea or a coffee, then wait until it's read completely, and then I have to filter.
And then the filter
yeah.
would take 10 minutes too.
Probably, yeah. If your memory is not collapsed, because putting 6 gigabytes in RAM, it's gonna impact your computer a bit. Right,
Yeah,
so if
mine
you
would
have,
crash.
yeah, if you have 8 gigabytes in your laptop, it's gonna take 2 for the operating system, plus 6 for the census database, and you are done. You get the bomb icon in RStudio. So, but with SQL, you can save yourself that problem, because you read exactly what you need to read, and SQL, because of index, knows where to read. Oh yeah, Julian, just go. You can watch the rest of the video later. Thanks for your attendance. Thank you, Catherine. Yeah, we are 2 minutes from closing, so we are gonna close now. I hope that you liked this workshop, and I hope it's useful, and the full table was loaded into the server, the 10 million observations table that we created.